Raise your hand if you ever had this embarrassing moment when business come to you and ask, I have a simple, I want to make this simple change, and you had to say, it's hard to do.
So Jan will talk now about back to simplicity, and the main idea will be to talk about the business logic and how can we deal with it. So a round of applause for Jan.
Thank you. Okay, so I'm Jan, and let me also introduce myself. So I'm from Wrocław in Poland. I learned recently that Bucharest is called Paris of the East. Wrocław is called Venice of the North, because besides being a beautiful city, we have more than 100 bridges. Fun fact about me is that I was in Bucharest when I was 4, at least that's what parents tell me, that I was 4. Obviously, I don't remember anything. I hope this time will be different. But if my parents are correct and I was 4, it means that was the last year of being Ceausescu in power. So my goal for today is to bring you another revolution. I work at Gainsight, customer success market leader. We don't hire any Ruby right now, unfortunately. But at least I would like to take the opportunity and thank my company Gainsight for being my travel sponsor. I'm also a Friendly.rb co-organizer in our annual conference. We conference ideas since 2012. And we hope that our next edition will happen in April next year. So as soon as we confirm the venue, confirm the date, we will open call for papers. So if you want to share your knowledge and experience in Wrocław next year, watch out our social media. Speaking of Wrocław.rb, 3 years ago, in 2022, we had a privilege to have few speakers that would say that were less known at that time, like Jarosław Szmarow, Paweł Strzałkowski, Sergej Sergienko, Chris Kaczynski, who is also speaking today, and last but not least, Adrian Mari. All the presentations are available on YouTube, if you like. And, oh boy, look at them now. You guys are my inspiration to finally make a step up and make a debut on a bigger stage. So thank you, but I also would like to encourage you to take the inspiration from their story and start sharing knowledge through public speaking. Speaking of inspiration, last year on this stage, Tom Rossi had a very great presentation, SaaS Lessons Learned, where he said, you will never know less than you know right now, which he also rephrased as, you will never be dumber than you are right now. It's a great phrase, but I have a problem with it. I feel dumber every year. Maybe it's just getting old. Maybe it's about parenting. Recently I read that men, after getting kids, part of the brain dies. But I really struggle with working with complex code. I really want to have a simple thing. But I also believe that code shouldn't be clever. It shouldn't be complex. Products should be clever and interesting, but code should be boring. Simple and boring. So let's get into some definitions, let's say. So things can be easy, right? Creating something in ways that communicates with the database is as easy as 2 lines of code. Just create a migration, 2 lines of code, and you can already create records, find them, update them, do a lot of stuff. So easy is about the effort. My favorite definition of what is simple is that simple is something that is not complex. But easy things can be complex. For example, in plain Ruby, also that was in previous presentation, bare object is 60 methods. If you install Rails, you already have 80 methods. This empty user class has 467 methods. That means that under the hood, this is a really complex thing. Because complexity is about the inner details, how things work under the hood, and what is the concept behind it. Raise your hand if you ever had this embarrassing moment when business come to you and ask, I have a simple, I want to make this simple change, and you have to say, it's hard to do. So most of the time it's just accidental complexity. Complexity that we developers introduce, and it is nothing about the business. Sometimes it's justified, Like if we make some design decisions that allows us to do some stuff easier or may have better performance or something, but most of the time it's completely unjustified. And it comes because we suck at predicting the future. So Race always had a focus to make it easy to achieve complex things. Probably nothing can beat Race to like get from zero to production and release your product for the market. Probably is the best solution that can allow you to make it in the fastest way possible. But nothing is free. And Race succeeded so much in achieving complex things in an easy way that quite often everything is complex now. And complex means that things are brittle, hard to change, hard to maintain, and they're slowing us down. And the fact is that projects start once, later on are just pivots. So what if we shift the focus a little bit? Like make it easy to debug and fix bugs, make it easy to adapt to requirements changes, make it easy to introduce juniors, and make it easy to read the code, because the longer the project lives, then the more we actually read the code and write the code. So how to do this? Fat model, fat controller, service objects. Now, and the best way to explain, at least for me, the best way to explain technical stuff is through some examples. The most abused one are like e-commerce, some basket or to-do applications, but I'm not sure if you can stand any more applications like that. So recently I started implementing board game. There is a real board game Fuba. If you are about board games and football fan, you definitely should check this title. It's probably the best title. Nicely represents football match on a board game. But you don't need to know the rules of the game, because we'll be just focusing on basic stuff like generic stuff like creating game, joining game, starting a game. So let's start a game. Create a game. In a Race way, that's one of the ways how we can achieve that, right? We have a user class, we have a game class, there is a connection between them, relation. We have a controller where we just have a create method, bang, we can call it end of the day. Minimum effort, maximum result. That's why we like Race so much. But let's make a step back and let's go back to the whiteboard and design the system. So what is the intent here? The intent here is to create a game. This intent can carry some data, like we can, for example, we can fill the ID of the game and provide ID of the owner. What will the effect of executing this intent? Well, the game will be created, right? It also has a name, like game was created in the past tense, and some data. But where this request comes from? Well, from the UI. I'm a perfect designer, so that's the UI sketched. There's a button where someone will click the button that we transfer into the intent and later on the effect. But who will press this button? Well, an actor, a player in our case. I never call it user. So how can we represent, and this blue card is called commands, let's call them commands, and this orange card, let's call events. So how can we implement them? Basically, if you are dry.rb fan, you can use dry struct. If you are literal fan, you can use literal data. If you don't like any dependencies, you can just use data. Whatever you will use is just a data structure. It has a name and some data, and that's it. It's that simple. If we simplify a little bit our case, we can even read off the command and just convert the request as a command, HTTP request as a command, create a new event and save it into the storage. We call the storage event store. And that's it. Now let's join the game. So we have another beautiful UI that represents a game with 2 buttons, 2 seats, home and away. Player can join the game. But how do we get data for this? Well, there's another card, green one this time, that provides data, answers some questions, and provides data for this specific UI. How do we get data into this block? Well, from the events from the past. from the facts that happened before. And now we can, in similar way, create a new command, join game, with game ID, player ID, selected seat. And this command will have another effect, another event that we can later on also connect with the read model, this green card, to update the UI, or just simply we can present that on the model, how it will look like. So the read model will be updated and the UI will be updated. Classical way to implement such a thing would be to extend the game class, for example, extend the game class with new references that will get params and execute some logic how we should update the game. But I would propose something else, a little bit more declarative way. I'm using the decider pattern. The decider pattern is something that deserves its own presentation that can take an hour or even more. But all that you need to know right now is that the decider pattern is composed around three functions. Initial state that just returns the state that we have at the beginning. The side function that takes command and state and returns list of the events that we decided that should happen. And evolve function that takes state and the event and returns new version of the state. And this is how, with small DSL that I created, can be implemented. So we have initial state. It's another data structure that represents, well, the state of the game where both seats are empty at the beginning. Then we have a decide block. I'm doing a pattern matching here. So I'm matching that whenever you get a command that tries to join someone to the game on a home seat, and home seat, the next argument is state, the home seat is empty, then decide that play and join the game. Similar thing for the away. So whenever someone tries to join the game on away seat, and away seat is empty, just decide that player join the game. And we have also evolve functions that will take facts from the past, like play and join the game and update the state. In the end, we have a very declarative way to express our business logic. It's hard to make actually, it's very hard to introduce bugs here, or if requirements will change, it's easy to adapt. And to execute this, we can have another controller method where we convert user request, HTTP request into the command and put it into some handler that we will just create it once in the lifetime of the project that will just know what kind of storage we are using, how to load it, how to handle race conditions, etc., and how to save the state after execution. You can say that this way is harder, but I would say that it's simpler. Let me explain why. If you take a closer look, you will notice that we can slice our design into very independent blocks. Each of these vertical slices is completely independent, can be built separately, and they have nice contract between them that and events act as this contract. Each event comes from just single slice and can be consumed by few others. They can be developed independently, they can be tested independently, they can be even deployed independently. Sometimes even as each slice can be like microservices if you like. We can even push this further, and each slice can have separate directory. Why? Because I believe that things that change together should stay together. So we have, instead of having a single game class that is used in dozens of places, everything that is connected to the single slice stays together. This is not this is not from the Race project, but thankfully Race is flexible enough that we can achieve similar thing. And in this slice we have our decider, configuration, event, test. I'm using Flex here, so I even have a UI. Everything that I need to create a slice lives in this single directory. Okay, let's start the game, and let's have a requirement that game should automatically start whenever both seats are taken. So we have another command, start the game with ID, and an effect that game was started. And it should be called by some automation. Automation is just another actor, like a human. Most people represent automation by gear icon, but because I'm doing football game, I just use ball. But how this automation will know how to execute the business logic? So the same way as any other actors, which are humans. So from some read model, we have to provide some answer to the automation, so we can know if automation should proceed with something or not. The only difference between human and automation is that human needs UI to read data, and automation can read them directly from the read model. And this read model, the same way as previous one, is built on top of some facts that we recorded previously. If we take a closer look, you can also use this notation to model tests. With given when then notation, you can model how we should test the system, how the system should behave in details. Like, given the game was created, when someone joins the game, we expect that player join the game. Or given the game was created and player joined the game to home seat and player joined the game to away seat, we expect that there will be a read model that there is game to start. One crucial thing here is to not think about the events like something that represents change of the state. Events represents business decision that was taken, and based on this decision, we can change the state or states. Because if you take a closer look, single event can impact multiple different read models that are specifically designed and prepared for different use cases. If you think that there's a lot of repetition in the code, yes. But dry should not mean don't repeat code. It means don't repeat knowledge. Because if something looks similar, it doesn't mean that it's the same. And things like command handler can be repeated, but knowledge in different areas of the application are completely different, and we should not repeat it just because it looks similar. Read model itself can be implemented in many ways, depending if you want to store it, what are your persistence, what are your performance requirements, if you want to make it reactive or projected or from cron. One way could be to use something similar to the decider pattern with the view that just evolves the state and calculates on the fly. You can calculate on the fly whenever you need to read it, or just calculate in a reactive way and save it for future read. And we would execute querying in a similar way, just create a query for the read model, have something that will know how to fetch data, build the read model, and return the result. So where is the complexity? And the complexity is the essential complexity of the business process. We call this timeline chapters. They represent some part of the business processes, and this is where is the complexity. We should put much more effort into understanding how business works, and each slice represents just this very simple thing. There are either command view, where you request for change, or read view. There's two patterns. And by the way, slices are nice because you can, thanks to them, you can even fire project manager or Jira, because you can just color code your slices, what is the progress, and you have highlight view, how much is left to be done. Gray for me means that it's not yet in progress, yellow that is in progress, green that is done. So you can, on the blink of the eye, you can know if the system is done or not. That also, there's a great article from Oscar, removability over maintainability. And this approach allows you to optimize for removability, because each slice is so small that it's so easy to remove. And you can remove them when they are not valid anymore, like for requirements changes, or you can easily just do some experimentation and read off. When you are not happy with the code quality, you can easily just rewrite and easier to adapt. They're also easy to estimate because each slice is so small that approximately they should take the same time. So if you design the full system, you can just count how many slices you have, and that's your number, how long it will take to deliver the project. This approach can feel awkward at the beginning, because anything that is different feels awkward. Yeah. As I said, there will be a code duplication that can also feel awkward. There could be some missing tooling, and learning curve could be quite high at the beginning. But this is one of the things that as you start doing this, you will never go back. And unfortunately, some games might be not compatible with that approach. So let's sum up. If you just need to speed and deliver to the market, Rise is probably the best what you can take to make it happen. When you start needing for maintainability, you just need two patterns to handle all kind of business logic. Command view and read view. Use vertical slices to narrow context. And by the way, if you want to make your agents predictable and work, they will thank you for narrowing context. If use vertical slices to optimize for removability, to increase the independence of team members, and simplify juniors and ALIs. Use event modeling. This technique with cards is called event modeling, and event storming to simplify understanding the system and defining and estimating your work. If you want to learn more, there's a great book. I think it was released last year. Examples are in Kotlin, but there is already a repository in Ruby, and code itself is really easy to understand. So I would like to dedicate my debut to Piotr Trzaskowski, who passed away more than a month ago after a long battle with disease. So Piotr was one of the first Polish Rubyists. He was also a speaker on first Friendly.rb in 2012. He left great legacy, and he was a very friendly guy. So rest in peace, Piotr. Thanks.
Thank you.